Okay, brilliant. Can everyone hear me? So yes, thank you very much, Anne, for the introduction. My name's Vince, and I'm going to talk to you today about research. I'm going to probably, let me just fix that. I'm probably going to repeat a fair bit of my introduction. I'm a mathematician at Cardiff University. It's probably the job I always dreamt of having as far back as I can remember, even before I really knew what a mathematician was or someone who works at university, what they do. I love my job. I love using mathematics. I love getting to do mathematics. And most importantly, I love teaching how to use mathematics. And I'm really, really lucky in that all of my teaching involves Python. I teach everyone in our school how to use Python to kind of take the mathematics that we do in our textbooks and with pencils on paper and actually use it, which I think is a phenomenal superpower. The bottom left logo is a logo for one of the game theoretic libraries that I'm a maintainer for. One of the other maintainers is at the back over there is Owen. Someone who I'm going to start by thanking. I've learned so much from Owen through this library and through other things about software and well, many other things. And this library will come up in the talk. It's a library for studying emergent behavior, so making assumptions about how we interact and seeing what is the actual behavior that emerges. Top right, I'm also a fellow of the Software Sustainability Institute, which is an institute interested in improving how software is used in research. And so this is a big part of my talk. Bottom right, I'm a trustee of the UK PA, and I am also one of the people that helps run this conference. I have to say, it really is a big deal for me to be keynoting this conference. It means a huge amount, because I've been involved with this conference and other versions of this conference for quite a long time. And I feel like I've kind of grown up with this community a little bit. I mean, I'm not finished growing up, but I've certainly learned so much from this community and from the people that are involved with. I have some friends here that I just can't speak highly enough. Daniele, it means so much to me to do any work whatsoever with you, and I really thank you so much. And you're doing an amazing job running this conference, and everyone else that I'm forgetting. I would also like to thank my beautiful wife, and our two children are here. They're enjoying the stickers, and I can't speak highly enough for their support. So Coccinelle and Papillon, I love you. I know you're watching the TV. You can keep watching it, sweetheart. The people that are doing that are over there. They're doing an amazing job. You should go see them later on if you want to, Papillon. Anyway, that's about me. What I want to talk to you about today is why I don't really want you to trust me. I'm going to start by talking about Wittgenstein, who, when I was reading about this person, is described in some places as one of the best philosophers of his time. I can't say I'm a philosopher, so I make no comment about that. But apparently they're very good at what they do, or what they used to do. And one of Wittgenstein's thought experiments is the following. This is our planet, or at least our planet if you draw it in a really cool TIX library for drawing our planet. So it's the planet Earth, and the planet Earth, if we assume it is completely a perfect sphere, I'm a mathematician, we do that a lot, it has a circumference of 40,075,017 meters. Okay, that is how long a rope would have to be if you went around our planet at its longest point. And I want you to imagine that rope, and I want you to imagine that rope's going down at your feet. Obviously, all of you have different ropes that are going down at your feet, but imagine you've got that rope going around the Earth, all right? And it's the perfect length. It is exactly the number I have on that slide. And so this rope is essentially hugging the Earth. There's no space between the floor. I realize we're above ground right now, but ignore that. Again, mathematician, we do that a lot. And it is just perfectly on the floor under your feet. What I'd like you now to imagine is the Earth is pretty big. Maybe we're wrong. Maybe that's not quite the right amount of rope we need, and we need the rope to go all the way around. So what we're going to do is just add 1 meter to the rope, right? Just add 1 meter to the rope. What I'd like you now to do is just think about that rope that's at your feet. What's happened to it? The Earth is huge. The rope is very long. We've made it a teeny weeny bit longer. What happens? Okay? Do you notice it? Is the rope incredibly tall? Is incredibly high off the ground, I should say, or not? Is it barely noticeable? Is it just a little bit more slack? And so what I'd like you to do now, if you want to, you don't have to, is turn to the person next to you, introduce yourself if you haven't already, and tell them what you think happens to this rope. Go ahead, do that now. So if I may interrupt you, and I hate to do this, if I may interrupt you, put your hand up if you agreed with the person you sat next to. Okay? Theoretically, I should only see pairs of hands that do that, obviously, but now, more interestingly, could you put your hand up if you disagreed with the person next to you? Okay, a few hands disagreed. So, I don't care about whether or not you agree, A, with what I'm about to tell you, or B, whether or not you agreed with the person next to you. I would argue if you disagreed with the person next to you, that's more interesting. The thing is, we know what will happen. What will happen is described by these equations up there, okay? The first equation, equation 1, is 2 relationships that show us essentially the same relationship, just with slightly different numbers. That's the circumference of a circle. So the circumference of a circle is 2 pi times the radius, well, that's it. I got a bit excited there. 2 pi times the radius is the circumference of a circle, okay? And so if we say the circumference of our circle is the rope, if we now say, okay, let's make C2, the slightly longer rope, be C1 plus an epsilon, we can calculate what our radius would be. And the radius is essentially the distance from the center of the Earth, or in our case, comparable to the distance from the ground. And so what we get that's really interesting, sorry about the mic, is that the radius of the second rope, the slightly longer rope, is going to be just a tiny bit longer than the original radius. What's quite neat about that equation, that some of you might notice, is that there's actually no C1 or C2. So my question has got nothing to do with planet Earth. My question is completely the same question, be it Mars or any other planet in any solar system, or an apple. If you take an apple, put a rope around it of perfect length, and then increase that rope by a meter, the answer is the same. What that answer is that if your rope length goes up by some measure, the rope height goes up by epsilon, that same measure, divided by 2 pi, which we can just plug in to get actual numbers for our actual Earth, means that we all have a trip hazard at our feet. The rope is all about 6 inches off the ground now, okay? So if you thought that it wouldn't make much difference, that's not right. That is simply wrong. It makes a difference. It makes 6 inches of difference. Your rope is now a complete trip hazard. And if you don't believe me, we can talk it out. I can go back to these equations. I'm not asking you to believe me, to trust me. If perhaps the only point that doesn't follow logically, and what's the slide there, is where we start, the equation for the circumference of a circle. If you don't agree with me there, if you don't believe me there, we can spend some time talking about that. I can prove to you that that is the equation for the circumference of a circle. Me, or indeed many other people, could. But what do we do when we don't have such a proof? And this was Wittgenstein's point of his thought experiment, was what do we do when we don't know something, when we can't know something, when all we have is this model of our thoughts, our observations? And that was the point, that some of you perhaps thought that, oh, the rope will be slightly higher off the ground, or, oh, it won't make a difference, it won't make any noticeable difference. What you're doing there is using a model of the world, your own model in your thoughts of the world. And in fact, we all do that all the time, okay? And so what do we do when we can't prove it? Because your model of the world, I don't care about it, frankly, because I can put those equations on the board and I can show you that that is a fact, all right? But what do we do when we can't prove something? I remember politics. I remember thinking about politics at a young age, going like, I find that hard because I don't know what is right or wrong a lot of the time. I have my own model of, well, I think it would be good to do this, but I don't know, right? Whereas with mathematics, and it's probably why personally I was kind of brought to mathematics, or came to mathematics. Mathematics, what I like about it is that you know it is what it is. Which brings me to talking about Kyrie Irving. Kyrie Irving is an incredibly talented basketball player. He's often described as someone with the best handles ever in the game. Handles means that he's very good at dribbling. He can do things with a basketball that's incredibly impressive. He has won the NBA championship one time, and is considered to be one of the best players in the game. He often makes the news for other reasons, though, for non-sporting reasons. One of which is he forego approximately $11 million in salary a few seasons ago when he refused to get the COVID vaccine. He refused to get the COVID vaccine, and the state in which his team is based had a rule that would not let him play basketball at home. His reasons for not wanting the COVID vaccine are not something I'm going to go into now, but Google them by all means. They're certainly interesting. But his essential model of the world, of that decision-making, made it so that he was not going to get the vaccine. He's also been in the news a couple of times because he is a flat earther. He believes the earth is flat. And he speaks quite openly about that. And so once again, his belief, his model for the world doesn't accept that the world is indeed a sphere. And so he's got no interest in Wittgenstein's thought experiment because the whole thing kind of collapses before we even start, because I put that picture of the earth up and he says no, which is fair enough. Now, the world is a sphere. We can take some sticks and play with shadows and see that. But the COVID vaccine, and perhaps his reasons are demonstrably unprovable, certainly is a hot topic, an understandable one. And so what do we do? Why did I get the COVID vaccine? I am fully vaccinated, and when a booster shot comes out that I'm allowed to take, I will take it. Why did I do that? I have the expertise to be able to look through all the data. I have the expertise to understand a fair bit of the papers that would be written about it. I certainly don't understand anything about the biological mechanisms of the vaccine, but I have some ability that I could read through these things. I didn't read any papers on the COVID vaccine. I barely read any popular press about the COVID vaccine. It's probably not quite true because it's hard not to. But I got the vaccine and I will. And I think the reason for which I did that, and perhaps a lot of us did that, is what's on the slide there. That is the peer review process. So for those of you who don't know how science gets accepted as fact-ish, perhaps, this is the process. Someone submits a paper. That paper with science is screened. Often this is to make sure that it's of the right file format and stuff like that. Once it gets past that screening process, it goes to a chief editor. The chief editor can at that point reject it, but usually they pass it on to an academic editor, and the academic editor can at that point reject it. They usually don't have the time to read it too thoroughly, so what they do is they then go to the next step, which is to find peer reviewers. And peer reviewers are supposed to be peers in the field, experts on the topic, that read the paper and go into a back and forth, supposedly discussion with the person who wrote, with the people who wrote the paper, and accept it as fact. So I got the COVID vaccine because I trust that this process has happened, and people who are more expert than me have checked that it works. Now, where did that peer review process start? And did it just kind of start like that? And that's kind of what I'm going to take us through for a little while now, is the origins of peer review and where we are today, and hopefully where we're going. This is a picture of the 12th century, a picture of a 12th century copy of the Hippocratic Oath that all doctors take to do no harm. It is not anything to do with peer review. It's just a really old picture, because one of the oldest documents that's considered, cautiously considered to be the first peer-reviewed document is a 9th century document written by Al-Rawi, attributed to Al-Rawi, called The Ethics of the Physician. And in this document, physicians, doctors, would write what they did with their patients, what they told them to do, what they did. And upon the death of a patient, peers would read what was in that document to essentially check if the physician did the right thing or not. Interestingly enough, I found reading about this is that it was first cases of medical malpractice lawsuits were happening as far back as back then. And that's cautiously attributed as the first form of peer review, which is kind of promising, right? Peer review was checking if people were doctoring properly. That was in the 9th century, taking us nothing really changes from the point of peer review until Gutenberg. Gutenberg is kind of attributed, recognized as the inventor of the printing press. There's certainly arguments that other people in other countries did it before him, but Gutenberg is kind of attributed to be the inventor of the printing press. This was a big deal, and this was fantastic because it meant that information could spread very fast and could be made accessible to a lot of people. This was also a huge problem because it meant that information could spread very fast and could be made accessible to a lot of people. And so the first kind of examples of peer review, and I'm using the word peer review a bit loosely because it's certainly not recognizable as to what we do now, followed where the church was deciding what could and couldn't be printed. This is Copernicus's work, where Copernicus presented a heliocentric, so the sun at the center of our solar system, view of the solar system. And the church was okay with this. The church was originally okay with this, and that's mainly considered to be a fact, to be due to the fact that Copernicus was a canon of a cathedral, of a church. When Copernicus died, the church changed their mind and decided that no, this was no longer okay, that the sun was certainly not at the center of the solar system, and that's why Galileo was burnt at the stake. So at this point, the peer review accuracy that the church had is probably at about 50%. It got it 50% right. There's a few other examples of this where, for example, Servetus presented an idea that blood went from the heart to the lungs, passed from one side to the other, and that was deemed to not follow dogma. And so Servetus was burnt at the stake. So at this point, the church is at a 33% accuracy in terms of their peer review, and I'm using our current understanding of how the body works as a measure of accuracy. But luckily, someone called Vesalius, I believe, and forgive me if I've gotten that name wrong, I suspect they won't mind, Vesalius presented the same ideas a little bit later, and they were accepted as being okay. And that was a really important thing because that all of a sudden let medicine progress. And at that point, the church is at about 50% accuracy in terms of its accepting of what is and isn't fact, a lot of which is just based on dogma, on what we believe, on this model of the world that we have. And nothing really changed for a long time again, until Francis Bacon published this document in 1620. And this document is considered to be pretty important and a foundation of the modern scientific method. Because what Francis Bacon said is, everything should be observable. Anything that we say as scientific fact should be observable. So, for example, going back to my equations showing the circumference of a circle, if you don't believe that the rope is now 6 inches higher, we can go back and observe the expression and the derivation and the proof of the equation of the circumference of a circle. You don't need to believe me. I can show it to you. And that's what Francis Bacon said in this document, is that all science should be observable, should be debatable, and should be examinable. And this led to change. This led to kind of swift change in terms of the speed of things. First of which, I believe, should be attributed to Oldenburg, who was the first editor of Philosophical Transactions, which is one of the very earliest scientific journals, where he actually chose a lot of things to be correct or not. He did start some peer review. So he did send some documents for advice. So in other words, he accepted his limitations of understanding and sent them to someone else to take a look at them. A big reason for that all of a sudden going faster was the invention of a carbon copy in 1890, which actually meant that getting a copy of a document was possible. It was, prior to that, these documents had to be rewritten, or just the originals would be sent back and forth. And so this is kind of when peer review started, where people would send some work and then people essentially would check it against these original ideas of Francis Bacon. Not everyone thought this was a good idea. Not everyone thought this was a good idea. There's someone that often gets attributed with quotes that are not quotes that should be attributed to them, but this is something that this person said. They did some work, they did some science, and they sent off their manuscript to be published, and they were aghast that their work was sent to peer review. This happened in 1931, and this was Albert Einstein. Albert Einstein was actually quite upset that some of his work was sent off to be reviewed by any old person that could say they were right or wrong. Now, I don't have much in common with Albert Einstein, but frustration with reviewers I certainly do. And I have certainly had work rejected, far more than Albert Einstein, certainly had work rejected by peer reviewers where I felt, why is this person that I don't know able to reject my work because they don't like where I've put my commas? And so that is certainly something that is a frustrating process and was deemed to be a big passing point for science, where instead of having these more important, more knowledgeable editors that could act as gatekeepers, that actually knew what they were talking about. Now, all of a sudden, anyone could say whether or not their work was right. This is a bit of a timeline of all these things. So as I said, Oldenburg kind of started what looks like modern peer review in 1665. Louis XIV did something important in France where he said that the scientific community didn't have to go through royal censorship. So he was the first one to separate science from really regulation censorship. The Royal Society in 1752 had a review committee to look at the effect of peer review. And in 1892, it was noticed that a paper was incorrectly rejected in 1845. And this paper in 1845 actually presented Maxwell's gas laws. It was not written by Maxwell. Maxwell presented his paper later on. And this was a big deal because, not that the author of the paper didn't get credit for Maxwell's gas laws, but it was a big deal because it was seen, oh, you see, peer review doesn't work. Peer review is a bad system because it can reject important ideas, as opposed to perhaps they would have been accepted otherwise. Despite that, peer review stuck around. Peer review as a system stuck around. 1973, it wasn't until 1973 that Nature, which is a very important scientific journal, arguably the most important scientific journal, it wasn't until 1973 that Nature explicitly said, you have to have peer review for a paper to be accepted. The paper has to be accepted by peer review. So in 1972, arguably if the editor liked what you did, your work could be published. Now at least we have that peer review system. The last two things are kind of the more modern era of things. In 1991, this server was set up. Some of you might know what that server is. I certainly didn't at the time. It's the archive. Some of you might not know what the archive is. The archive is the first accepted preprint server. And so before, just to allow your work to be read, you needed to get it to be published, unless you actually literally sent it to someone, obviously. Now, there are many preprint servers, the first of which is the archive, where people, when they do their work, or when a new planet is found, or a new exoplanet is found, or when gravitational waves were first detected, and various other things, the first place that work appears is on the archive. And that's essentially just a preprint server where anyone can check every day new papers and can read them if they want to. But essentially, no one is checked if they're right or wrong. The next one is perhaps not as a big deal or is not as ominous as these other ones, but PLOS ONE is a journal that was started in 2006, and PLOS ONE makes a point to omit importance of the work in its reviewer guidelines. So reviewers are asked not to consider if the work is important, just to consider if the work is correct. In other words, letting the importance of the work be decided by those who read it, and not the 2 or 3 peer reviewers. But that's an important step because the actual correctness of the work is where we are. And correctness of the work is, despite all this, despite all these systems, not always the case. Sorry, everybody. You're doing an awesome job, Donnie. Despite all this, there are still errors that happen in the scientific process. So this was a headline that made the news. The counts for COVID in the UK were quite wrong. We're wrong by a fair bit. I'm afraid that the next few slides are somewhat Excel-y bashing, which I regret, but it's more the use of Excel that's being bashed. Excel was being used incorrectly to record COVID outcomes, and so we just forgot a lot of people that died from COVID, and all of a sudden our death totals jumped up. This is one that I didn't know until speaking to Daniele about my idea for this talk. There was a lot of people who thought they were doctors, and were not, because whether or not they passed a particular module had been done incorrectly in software, and they had to essentially stop being doctors. This is one that gets brought up a lot that I think is quite amusing.
I got to go now.
Okay. Julian, I love you too. See you later, okay? Bye, Coccinelle. Bye, Papillon. Sorry, I'm trying not to cry right now. So this is a good one that gets brought up a lot. The latest approximation that I know is in this paper. They reckon that about 30% of all genetic research could be wrong. And that 30% number comes from the fact that a lot of the time genetic research is done in Excel, and a lot of the time when you put genetic names in, which could be a string of characters or a string of numbers, and you put them into Excel, Excel helpfully changes those to dates. And so about 30% of genetic research could be wrong. And this paper is actually a follow-up to the first paper that approximated that it was 20%. And what this paper was saying is, since our last paper, you're not fixing this. You're not doing anything differently. So we think it's actually going up. I realize this slide is probably not terribly helpful for those of you at the back, so don't worry too much about the details. This slide, and the main point to see on this slide is that there's a straight line, and none of the different sets of colors of points are all on that straight line. So none of the points match the line. That's the important part. A lot of my research revolves studying the iterated prisoner's dilemma, which is a mathematical model of the emergence of cooperation. And in the 1980s, a gentleman called Robert Axelrod started a computer tournament where people wrote computer code and got these computers to essentially interact with each other, and based on how they were programmed, either cooperated with each other or didn't. And it's a really cool bit of history, but also a very cool current piece of research. And he wrote a big computer tournament, and people sent in code. It was written in Fortran. And this code is still around. You can go on Robert Axelrod's website, and you can find it. It's written in Fortran. And this slide has actually been presented at PyCon UK before by Owen, who took this Fortran code and wrote a really cool wrapper to essentially use the Fortran code from within our modern research tool for studying the prisoner's dilemma, which is a Python library called Axelrod, which runs all these things, essentially trying to reproduce the work. And that's really cool. It was such an awesome piece of work by Owen, because we're not reading the Fortran and trying to understand it. We're not, although we have done that as well, which has been interesting. We're not changing anything. We are using exactly what is supposedly being done. All right, so fantastic. The code's available. We're using it. And importantly, the results don't match. Right? So even with the code, the results don't match. So in this particular case, either the results written by Robert Axelrod in his original paper are simply wrong, they're not what happened, or the code is not the actual code he used. Impossible to know which, and that's that. So to some extent or another, the paper written by Robert Axelrod isn't doing what he believes it's doing, right? It's not what he believes it's doing. And so again, what do we do in the absence of proof? What do we do with all these things where we have to make some leap of faith to the research, right? That the peer review process that we all count on makes mistakes. What do we do in that case? And there's this interesting paper that was written in 2012 saying, is expert peer review obsolete? Is this idea of 3 peer reviewers obsolete? And the paper is here. It's very, very short. And what it does is it says, okay, let's model expert peer review. And let's model expert peer review and compare it to reader review. And reader review is the idea that maybe you'd use the preprint server and Before 3 peer reviewers read the work, 50,000 people might, or maybe 50 people might read the work. And if we could get everyone's decisions, what of a difference it would make? And so they model this by saying, okay, a paper has a true value, whether or not it's good or bad, and a reviewer will just essentially add a little bit of noise either side to that paper, right? A perfect reviewer, if a paper is an 8 out of a 10, a perfect reviewer will say it's an 8 out of 10. What this paper does is it makes these assumptions and adds a little bit of noise to the review. They have an expert reviewer where there's a little bit less standard deviation around that noise, and they have a reader reviewer where there's a little bit more standard deviation. The idea being that a peer review is an expert in the field that's been targeted, that's been chosen, and an expert reviewer, well, that could be anybody can read this work, okay? And so what we can do is we can try and reproduce this work. And so I've got a Python notebook here, and I've got some code in a main file, and you can look it up. And so create manuscript is there, and what it simply does is it samples a random integer from the numbers described in the paper. And that, for example, has sampled 100,000 papers from the distribution that is expected to be done. Then the paper describes the review process, and so we can reproduce that. The review process is explained there. The idea is you sample some imprecision error, then you sample some other error, and then you add those 2 errors to the actual manuscript value. You clip it so that it stays between 1 and 10, and we can go through and get the average review scores. So the simple idea is that you just repeat the process to get an average review score, because that's what the idea is here, is we say, take out 3 peer reviewers. Me as the academic editor, I will listen to what the 3 reviewers say and get some sort of average idea in my mind. And so if I do that, we can get all these different papers, which ones are accepted, which ones are rejected. And the paper has one really interesting thing. Sorry, that's doing it a service. The paper has one main point, which is this table at the end. Well, it says, if we have, what is the accuracy of 3 expert reviewers? First, if they were averaging, and second, if they were voting. So if we have a threshold that we only accept papers that are an 8 and above, and we just get a vote or reject result, can we get the same level of accuracy as the paper? And we have the 3 expert peer reviewers, and we have the reader peer reviewers. And the big conclusion of this paper is that with 50 reader reviewers, we can get an accuracy of the voting process of 97%, 0.92, which is slightly better than the average process of 3 expert peer reviewers. In other words, reader reviewing can be more precise than expert peer review. Sounds fantastic, sounds great. Maybe that's the next step in the process. And I'm actually making no comment about whether or not that is the next step. I don't know, maybe not. But let's try and reproduce the paper. So this paper about whether or not science is good, let's try and reproduce it. And give it a couple of seconds. And I'm actually using the exact same parameters in the paper. And this, if it was reproducing the work, would be a 97, not a 95. So I can't quite reproduce the work they've got. I can't come to the same conclusion. Maybe I've made a mistake. And should you trust me or should you trust that paper? I don't care. Trusting that paper is difficult because frankly, you've read it. I know it was on the screen, on half the screen for about 5 minutes, but that's pretty much it. However, if you want to trust me, and I don't want you to trust me, I want you to accept what I'm saying, you're very welcome to go to this GitHub repository, check the CI process, you can look through the code, you can, more importantly, look through the tests of the code. Seen a lot of hypothesis talks, and so there's a bit of hypothesis in there. And so you can check what I think the code is doing. Not what I say the code is doing, but what I think the code is doing. So please go and check, and by all means PR, and maybe I am missing something. That would be a good thing. If I am missing something, if someone is able to fix it, that would be a good thing. But fundamentally, you don't have to trust that I've written the right code. I am telling you that the code is doing what I think it is doing. And so I'm not even at the point of whether or not I've written good code, whether or not my code is a good model for the peer review process. I'm just trying to say it does what I tell you it does. And that's the only thing that I'm worried about at this point. And that kind of leads me to what is the next age of peer review? Where are we going with all this? And I think this is the past stuff. The first chunk was the church was kind of deciding what was dogma and what wasn't. Then there was, following from Francis Bacon, understanding of the importance of everything being observable, leading to peer review. And now we're getting to the new kind of stuff and what I believe will be the next stage. So we've got the archive, which allows anyone to read the work and make a judgment. And then journals like PLOS ONE, which have attribute importance to whether or not the work is correct. Whether or not it's important or well done is kind of secondary. So what comes next? And to go back to this process, I think that what I described very passingly as almost a non-event, the screening process, I think that should be a bigger part of this process. In that, when I've reviewed work, and when I know many other people have reviewed work, I've not gone into the details of checking things. I certainly know people have reviewed my work and have not gone into the details of things. And they have trusted with whether or not I've done something correctly or not. And I'm not suggesting everyone should do their research using hypothesis and having CI on Git. I mean, to be honest, I am suggesting that. I think we should do that. But I know that's perhaps not realistic. But there are certain things in research that we can simply know is correct or not. So has Excel changed some of these genes to be dates? And if the answer to that is yes, the review process should stop. And that should be an early kind of a flag. Which leads to kind of an interesting thing, which is where do publishers sit in this? And publishers have very little power because, to be fair, everyone in this process are actually peers. It's mostly academics doing this work off their own back, their own time, which is also why it's not always done to the highest standard, because academics don't always have that much time, so peer reviews can often be rushed. And publishers are often seen as predatory, frankly, as making huge amounts of profit without really adding much value. I'm not one to stand here and be defendants of publishers, but I wonder if perhaps if a greater role was given to publishers to actually check if the work does what the authors say it does, like, for example, running the test suite, if there was one, and if it was on GitHub, and used hypothesis and all those things. That could be a good thing. There are some journals that already do this, not where the publishers do it, but for example, the Journal of Open Source Software, which is a journal specifically set up to publish papers on research software. One of the jobs of the reviewers is to check that the software does what the software says it does, and that's very explicit in the checklist. And so I think in all research we should question, is the work doing what the authors say it is doing, what the authors believe it is doing? I had an email back and forth with one author of a piece of game theoretic research where they disagreed how I implemented some of their work in the Axelrod library, myself and a peer. And eventually the email back and forth just kind of stopped where they realized that they hadn't done what they said they did in the paper, because my response was always like, I'm just doing what you said. And it turned out that they just didn't realize what they didn't say, what they thought they'd done. And I think that's a fundamental check that's gotten lost somewhere. And I believe that if we put that in this process, science would not be fixed, but be slightly incrementally better, and this process would be more trustworthy. Here are some of the things that are attributing to fixing these. Some of you might know these. The Software Sustainability Institute, that top left link there, is really interested in how we have this slow culture change of not only the importance of software, but how to make sure software is done right. Research software engineers actually came out of that. Some of you here are probably research software engineers doing amazing work again, improving the work done, the way work is done with code. But I wonder how often the people who write the papers are not always the research software engineers. I fundamentally believe it should be. And how often the people that are writing the papers describe things that are not actually what is done. And how do we fix that, I think, is a fundamental problem. The carpentries, that's a whole set of lessons and courses that exist to try and improve the use of software in research. And then I mentioned the Journal of Open Source Software. That's the link right there. And that's where I'm finishing today. I was talking to Daniele about this talk, and I was like, I don't quite have the solution that I was hoping for at the end of this talk. And I don't know if there is one. But I think fundamentally there is a problem about whether or not the work that we read and do does what it says. And unless we have that, we can't really know whether or not to trust it. And I think a lot of the stuff that's being discussed, Hannah's amazing talk yesterday, where, again, a software error was discussed, we can learn and improve how software is used in research. So if anyone would like to ask me any questions or follow up any of this, here's some information about myself. You're very welcome to get in touch, and that's all I have to say.
Thank you, Vince. That was very fascinating talk. So we do have time for questions, and we do have a roving microphone in the room by my lovely assistant, Owen. So if anybody has a question, if you would just like to raise your hand, and Owen will appear with microphone. Just right down here at the front, Owen.
Thank you, Vincent. That was really fascinating. And one of the things you started out with was this question of what's the really firm place to stand on, and you kept coming back to, do we have a firm place to stand on? And I have a question about when you were presenting the tables of the accuracy and the different ways in exactly. So, and you said, oh, well, this group reached this level of accuracy, and that group reached another level of accuracy. Where is the God's eye view that knows what the real number is in the first place? I didn't understand where that came from in this.
Yeah, it's a very good question. So in the modeling they do, they make assumption about the God-given value of a piece of work simply by sampling it randomly. So they sample 100,000 papers by just sampling 100,000 integers between 1 and 10 inclusive. And that's kind of considered to be the actual value of the work. But, in a way, that's a fundamental issue in that, peers of mine in the room will have had experience where reviewer 1 says everything is great with this paper, don't change anything, and reviewer 2 will send a 3-line email saying, well, this is absolute garbage, it's all been done before, here are 17 of my papers, please cite them. So what is the actual value of the work, I think, can be a subjective problem, and is fundamental to this issue of should it be, or should that be something that comes over time with more readers, with more use, and maybe what we should concentrate on is simply correctness. And so in other words, to come back to this work, what you would have is a much simpler modeling exercise where you would say so many pieces of work are correct, so many pieces are incorrect. For example, 30% of genetic research is wrong, 70% of it is correct, and all we're checking for is whether or not that's right or wrong. Which with software, I think we can check that. Of course, there are going to be cases where it's not as simple as that. But in scientific kind of things where it all stems back to Francis Bacon's idea of observability, I think that's what we should strive for more than the importance, how good or how bad it is, just whether or not it's right.
Anyone else with a question? Halfway along on the left-hand side here.
On the topic of Excel, various programming languages have static checkers / style checkers with varying degrees of success. Is there anything like that for Excel?
I don't know. I don't know. Sorry. But yeah, that would be helpful, right? And I guess maybe to pause on that a little bit, I know Excel bashing is very easy, is fun. It is funny that if you put a gene name into Excel, it goes, oh, that's a date, right? That's funny. But fundamentally, it's a tool that can be used like any other tool, properly or improperly. I've lost days doing something that when I look back has been really funny and annoying about something that Python has done, right? I'm like, why would Python do that? That's so annoying, right? So Excel bashing is fun, but it's fundamentally a tool. I know there are a lot of workshops that exist about how do we use spreadsheets correctly. I think the solution of saying like, stop doing genetic research in Excel, that's obviously not a good thing to do, is not a good solution, because again, we're talking about culture change. So there are a lot of, I think the emphasis should be on the question you're asking, can we do something to make using Excel not make those mistakes? I don't know the answer to that, but I think that's the right question.
It's just occurred to me, like when you were answering one of the other questions, but do you think there's a danger if everyone has the Jupyter Notebook or whatever as part of the paper, and they just run that and get the same numbers at the end as in the paper? They'll be like, oh, okay, yeah, that seems legit. And so by what you're doing in this example, where you're having to go through and recreate the same steps that the author is doing, you're giving the result like more validity if you get to the same response, same result. Whereas if you're just rerunning the Jupyter Notebook and seeing, yeah, same input, same outputs must be right, you're kind of losing that check, if you like.
It's a good question. I don't think the answer is Jupyter Notebooks. I don't think just having the code executable is the answer, because I agree, right? You could have code that's wrong, and if you just run the code, it breaks down. So I would almost say, if I'm understanding your question correctly, because I'm not 100% sure I am, I would almost say that the Jupyter Notebook is irrelevant to the question, and the importance is having, I don't want you to trust the Jupyter Notebook, I think is what I'm saying. I want to make it, and I think it is the responsibility of the people doing the science or publishing the science to make it easy to check what is being done, regardless of whether or not it's in a Jupyter Notebook. But I'm not 100% I've understood your question, so please correct me if I haven't.
Any other questions? Just in the middle. Oh, sorry.
Yeah, thanks. Over the last few years, we've seen the rise of kind of independent fact checkers responding to and reacting to things that have already been published. I wonder if you think this is progress or regressing back to those earlier days of having the church as a fact checker.
That is an awesome question. I can't say I'd thought about that. And I'm hesitant. Your question makes me think you've thought about that more than I have, which is awesome. And I'm hesitant to give my immediate naive response, which is, no, fact checkers are a great thing, because I suspect there's some reasons I can't think of for which they're not. But I think I am suggesting to some point stuff that is correct or incorrect, stuff that's not on a spectrum. There is certainly an obvious benefit to that being checked when it comes to research. Yeah. But I'd be fascinated to have a chat about what are the negatives of a fact checker, because in my mind immediately it's like, no, it's obviously right, but it'd be great to know why it's not.
There was a question sort of in the middle. Owen, just here, left-hand side. My left-hand side.
Did the paper go into any detail of when they were selecting for what is the standard deviation of the reader reviewers rather than the expert reviewers? Does that talk at all about how in that model, if you're just putting it for anyone to review, you can end up with situations where there's malicious actors about it? Where we've seen so much with fake news recently and things like, if you had one talking about the rope around the earth paper and then some flat earthers decided to brigade the reviews, how would that handle that?
Yeah, that's a really awesome question. And as I was, this paper is lovely. It maybe does what it says it does, but it's quite a straightforward paper. It's essentially sampling from a normal distribution a couple of times. And it doesn't take into consideration that. It doesn't take into consideration what if you get malicious actors? What if you get lots of predatory practice exists in publishing, for example, with co-citation networks where people cite each other or cite themselves via citing each other. So there's a lot of kind of malicious and strategic behavior. The answer to your question is no, the paper doesn't consider that. It's just at that overall level. As a game theorist interested in emergent behavior, this paper would be kind of the start of a study that I would do on this, looking into all those aspects you've said. So I definitely encourage you to take a look at that. That would be really cool to do. And you could think of ways you do that, right? You could think of ways like, oh, I've had an unfair review, so I'm going to act more unfair. And there's a lot of that kind of culture in science and academia where people go, nope, everyone has to learn how crappy peer review can be and how hard it is. If you don't like a paper, just say, I don't like this paper. And tough. Everyone has to be toughened up. And you could certainly kind of look at how that happens. But they don't do that. But it would be really interesting to do that.
Any other questions? Just on the far side? Yeah. They kind of went up at the same.
Thank you. Hi, Vince. Thanks for your talk.
Hi, Peter.
It's good to be back. You've touched quite a lot, and the questions have touched also on reproducibility. I think that's pretty key, isn't it? Having assurance that a paper is correct. Are you aware of any journals or any fields where the reproducibility or the reproduction happens before publication, so things don't get published until they've been reproduced?
It's a good question. So I'm not aware of many. I know a little while ago there was something called overlay journals, and these overlay journals, the idea was, let's put a journal on top of the archive, and so people can just put something in the archive, and then there were these ideas having like thumbs up, thumbs down on the papers that anyone could do that. I don't know, but that doesn't mean that they don't exist. I don't know of any kind of formal approach that has kind of embraced the reader review system. But I'd love to hear about it. I'm sure if they exist, someone in the room probably knows them. So, yeah.
I think we've probably got time for one more question. There was someone in the middle here. Yeah, who had their hand up. If you just wait, because then the rest of the room can, you wait for the microphone and the rest of the room can hear the question. I realise she says that whilst not speaking to me.
Can I ask about the environment? If the environment is high validity or low validity, so some things are unproven. I talk about economics is very difficult because it's a low validity environment. Should papers be downgraded if they are in a low validity?
That's a really interesting question. So please let me know if I'm understanding correctly. I believe you're asking, there's some, so for example, in mathematics, most fields of mathematics, some for subfields not, but most subfields of mathematics, stuff is either right or wrong, right? It's validatable, but then like in economics, there's a lot of, and other fields that we simply can't write unit tests to check some things, right? And then you touched upon, should stuff that is low validity, so not easily checkable, should that be kind of given a lesser importance? I don't think so, because I think the ad absurdum of that is all of a sudden we're saying that works of literature, works of art, and lots of works in the humanities are less important than scientifically provable things, which is wrong. So I don't think that's a good idea. Perhaps though, in scientific work, having some kind of level of clearly explicit confidence about how easily some things are checked would be a good thing. But I don't think they should be, downgraded or upgraded or anything like that, because I think that leads to where do you put the boundary on the importance of the beauty in a painting and recognizing, the author of a painting simply by how they painted the back of a dog.
So I think we're out of time really for questions. So if you'd just like to join me in giving Vince a really big thank you for his talk and the questions today.